Guys, welcome back to our channel. Solve the 9th question by leetcode. Our question is maximum width of a binary. So our video will be divided into three parts. First, the question discussion, second, the solution discussion, and third, the coding and implementation part, and at the end, the solution. So what we have given a binary and we have to find the width. So in this case, suppose if we have this whole binary, what will be its width? So first of all, what is width? We have to understand that thing. So the width is first calculated among the levels only. So first we will calculate for this, then for this level, then for this level it will be 1, for this level it will be 2, for this level it will be 3. So how it will be 3? Sorry, it will be 4 for this level. So for this level, how it will be? So first node, second node. This will be our third node. Now in between them, these both nodes, one more node will be there. So for that also we will consider. So our nodes will be 4. So the number of nodes which will be inserted between the two nodes or two separated nodes will be our answer. So in this case, first of all we will take the leftmost value and then we will take the rightmost value and then we will subtract that value, or then we will find their between values. So in this case, what it will be 5, 3, null and 9. Basically what we have to do, we have to find the width. So the width is the distance between the two leaf nodes. In this case, the distance is 1 unit. This will have one more subtree, or sorry, one more node, third node, and this is 4. So answer will be 4. Now suppose we do not have this. Now what will be our distance? So we will consider this. Sorry, we will not have this also and this also. What will be our distance? This both, we consider this both 1. The distance in these both. This is how we have to find the distance. So how we will find the distance? The main thing. Now if we found some index or some indentation by which we can represent the binary, then easily by subtracting we can find the difference. Now let's suppose we have this as a binary and we have to find the difference between these and this. So we can easily find, how we can find this by 6 minus 4 equals to. Now if we have some formula, or if we apply some formula such that the value which is the node is storing is according to its position. Suppose here 1 is there, here 2 is there, here 3 is there, here 4, here 5, and if one more node, here should be 6 and here should be 7. So how this will help? This is the main thing. So we all know that if we have proper indentation, then we can find. Now in this case, if we do not have these three and we have to find the distance between these, so how we can find? This minus this plus 1. So what it will be? It will be 3 minus plus 1. Similarly, if we have to find for this one, so it does not have left, it does not have right, so our answer will be 1 only. Basically what it will be minus 1 minus, sorry, 1 minus 1 plus 1. So it will be. Now how will indent these leaf nodes? So this will be 4, this will be 5. Now the value will come here, will be 6, this value will be 7. So what is our answer now? 4 minus, sorry, 7 minus 4 plus 1. So it will be equals to 4. So now we does not have this node. So what will be our answer? The same thing. 6 minus 4 plus 1. It will be. So we know that if we have some indentation, then we can find out easily. Now how we have find it out, this indentation? This is the main thing. So now we look at that, how we have find out this indentation, or how we can replace the values of the tree such that the index or the indentation comes at that values. So suppose we have this. Now I have removed this 6y because this is not correct, and I'll tell that why these all indexes or why all these are correct. So there is a formula for binary tree that the left of a parent will be twice of it and the right of a parent will be twice of it plus 1. So what is the formula? For left it will be 2 into parent, and for right it will be 2 into parent plus 1. So in this case, what is one side? It will be what is its left, what is its left is 2 into p, and what is its side? 2 into p plus 1. So it will be 1 into 2, so it will be 1 into 2 plus 1, so it will be 3. Now similarly, if we will do for this also, 2 into 2 4, 2 into 2 plus 1 5. Now if we have to find out for this what it will be, according to me or according to the formula, it will be 7. Why 7? Because 2 into 3 6, 6 plus 1 7. Now if we want to find out for more leaf nodes, now if we want to find out for this, so what it will be, we will find out for this. How we will find out? This will be 4 multiplied by 2 8. Now I want to find out this value, so what it will be? 4 into 2 plus 1, so it will be 9. Now what it will be? 5 into 2 10, and what it will be? It will be 5 into 2 plus 1 11. So this is how we have find the values. So we know that how to find the values, and now we all know that how we can find the values or how we can find the answer using these values. So what we will do, the first thing, first of all we will find these values and then we will do subtraction. Now for subtraction, what we will do each time, suppose we are on this index, we'll take this as example, and we will take its level. So we will traverse this by level. First we will go on this level, then we will go on this level, then we will go this level. So we will traverse this by a level or y level. So if we are on this level, we have the first node, we have visited this. So in this level we have first node visited this. So in this level we have first node visited. Now when on each level we will visit on the first node, what we will do, we will keep track of that, and when we will track the last digit, we will keep track of that also. So what we will do, first of all we will keep track of left, and then we will keep track of right, and after every execution of a level we will subtract the values and find the answer. So in this case, after the first execution our answer will be 1, after the second execution the answer will be 2, or after the third execution the answer will be 4. So at the end we will find the maximum one, or after execution we will find the maximum. First of all we will find the maximum of this, then at the end we will find the maximum of this. So now why we are finding the maximum? You thought that the last node will be the maximum value. Now suppose this will not be there and this will not be there. So what will be the answer? For this one, answer will be 1 only, because 4 minus 4 1. So our answer will be 1. So 2, and here it will be 1. So 2 and 1 maximum will be 1. So this we will consider. So this is how we will implement this. So now we'll implement this using the code. So we will see our code and then we'll submit our solution. Now let's look at our solution. So this is our solution. So first of all I have initialized the answer. So the answer at the end I will find of the values. Now what I've done, I have created new only, or sorry, I have created a tree or a duplicate tree like this to find the answer. Now I have not totally created a tree, but I have created a queue. Now what this queue will do, this queue will store each level one by one. So in this first case it will go first level, in case it will go second level, in third case it will go third level. So this queue we have declared. In this we have a pair, first the node or the node itself, and second the value which we will calculate. Now we are checking if root is a value or not, or sorry, have some value or not, means the value, the root is null or not. So if it is null, then it will not push back, and it will check that empty or not. If it is empty, then it will. So after this, suppose this is not empty, if we will this, so in the queue root 1 will be pushed. Now you must notice one thing, that the similar question I have discussed before only. So for that question, if you want to see that question, I'll attach of that question in my description. So both have same solution. In that also we have on this traversing, same traversing, the level traversing, and this also we have gone for the level traversing. Now before entering the while loop, we have checked that it's empty or not. Now suppose it is not empty. In this case it is also not empty, because I have checked the root and 1. So 1 will be the initial value, we all know. By the indentation also it will, the value we have calculated also be 1. Now we have calculated this count. Now what count will do? Count will help us to iterate over all these values. Now initially count will store 1, the one node only. Now what count will store? Count will store the number of level, or sorry, the nodes at each level. Suppose at first iteration it will store 1, at second iteration it will store, at third iteration it will store. So the nodes which are present in the tree, the count will store that. Now we have created a left and right. So in this I have not initialized the right, because what left will be? Now in this case left will be the first node. So first node we have already appended or already pushed back. Now the first value or the first node's value will be our answer. Now second or first, you all know, if you read about STL, then you all know that second will point to this and first will point to this. So second will point to the value. So in this case it will be 1. We have initialized here, so it will be 1, and we have not initialized right, we have just declared. Now I will go into the loop. Now what this loop will do, this loop till here, what this is doing, just this is just finding the rightmost, or sorry, the leftmost, or the rightmost value of the level. So in this case, first the first value which we will get, we will push back that value, or sorry, we will take that value. Suppose in this case we will get this first value, so we will take this value. Now we will make this value as right, because the value in this will be the rightmost till now. Suppose we are on this, so this value will be the rightmost. So these two conditions I have explained, that this node, the current node, and this the rightmost part after every execution. Now this value will be popped because we have traversed this. Now two more values will be pushed back, first the left value, then the right value. Now the left node will be pushed back and the second will be the value. So in this case what it will be, what its value will be. So in this case it will be the left, what it will be 2 into right. So right will be the parent. At every case right will be the parent, that's why we are taking. So right will be the parent, so parent into 2 will be the left, as I have explained before, and the right will be 2 into right plus 1. We have explained this also. So don't confuse between these two rights. This right is the long int, or this is the integer type. Now this right is the indentation or the part of this tree in which this left and right two nodes are there. So now after this I have checked that before storing the values only, I have checked that the value or the node exists or not. If not exists, now in this case our left and right in the first execution, in both it will be. So now you will apply the formula, the max of answer and this. So in this case it will be 1 only, the maximum value. So till now our answer will be 1. Now after when it will traverse this one. Now in the queue these 2 and 3 will be stored. So again it will go into the loop, so size will be 2, so now the loop will iterate 2 times, and this will iterate on these both values. Now these both child will be inserted, and like this will go to the endmost part and will find the value. Now I have submitted the solution and I have got correct answer. If I see more details, so it is faster than 80% of the ECPP solutions. So I must assume that this is the fastest solution, because in this it does not require to iterate over all the values again and again. We once traverse the whole tree, by whole binary tree, and then we have written the values. So this is the implementation of this. So in this the memory usage must be high, because we have created one more binary tree or one more level binary tree. That's why the memory a bit high, up to 50%.